Hey guys, welcome to another video. So today, another video in the final question series that I've been doing. So today's video comes from the advanced syllabus from Gosford's 2024 trial paper. Now, final question. This question's worth 8 marks, right? So that's a lot of marks for one question. Also, well, there's 3 parts to the question, but one concept, right? Today's question comes from the topic of probability continuous random variables, right? You know, in tutor maths, it's up there as like, one of the harder parts, I'd say. It's up there with like optimization and financial math. So, um, you know, question itself might be a bit challenging. It's not actually that technically difficult, but might catch people unaware. So now, before I begin, as always, guys, if you haven't already done so, please subscribe to the channel, tell your friends, and then once you watch this video, like the video. Guys, let's dive right in. So from Gosford's trial paper here. So let's have a read and see how we go. Continuous has PDF, right? Not CDF, of this. Okay, nothing too difficult apart from the fact that it looks a bit complicated. Okay, show that K is that. Probably going to use total probability rule, right? Where the integral from the limits of 0 and 3 equals to 1. 3 marks for that. Wow, okay. Okay, the graph of the density. So this is the graph of the density function, okay? Without any calculation, explain why the mode is greater than the median, okay? Interesting. And find the mode, okay? Okay, 4 marks, wow, that's a lot. Let's do this. So, part A. Now, to show that, remember, from a theory point of view, right? The integral from the lower limit to the upper limit of all of the PDF always has to equal to 1, right? Total probability, yeah? Sum of all probabilities equal to 1. In this case, the integral from 0 to 3 of the function, I'll take k outside as a constant, sine pi x plus 2x plus 2x dx equals to 1. Let me just make sure that's right. Okay, yep, fair enough. All right, let's integrate now. Integrate sine becomes negative cos pi x and then divided by pi plus integral of 2x is x squared. The limits of 3 and 0 equals to 1. Okay. Try to make k the subject. So basically, I'll sub in numbers to this, sub in the limits. So negative cos. Now, this is really important. I say this to my students all the time. Whenever you're integrating, everything's in radians. Never use degrees, right? So when I sub 3 in, that 3 pi there, right, that's in radians, right? Just keep that in mind, right? 3 pi on pi plus 3 squared minus cos 0, I guess, over pi plus 0 squared equals to 1. Now, what am I hoping to prove? Hoping that, okay. Okay. So pi, let me clean this up. So cos 3 pi. Now, cos, that's the same as cos pi. Cos pi is -1, right? So that's like -1. So that's 1 on pi plus 9 minus, and cos 0 is 1, so minus 1 on pi plus 1 on pi. Yeah. 1, guys, feels like I'm gonna combine and common denominator everything. Maybe common denominator now. I put pi down here, and it'll be like 1 plus 9 pi plus 1. That is exactly what I want. So therefore, k equals to chuck the pi over, and then 2 plus 9 pi. Perfect. Yeah, nothing hard about that, hopefully. Right, just a bit messy, right? A bit messy, but make sure everything's radians, right? And that's especially important for part C. All right, that's part A, done. Now, part B is interesting, right? It really helps understand helps you to understand the differences between the mode and the median, right? When it comes to probability density density functions, right? So I got mode and median. Now we know that the mode, if I have a sketch of the PDF, the mode is the most popular, right? The highest frequency. The highest frequency is the maximum turning point, right? So basically this guy here, from that point there, go down, I find the X value, that's the mode. Now, what's the median? The median is defined as the middle score. And when we look at middle score as it relates to PDF, right, the probability density function, it's basically the point where the area on the left equals to the area on the right. So for example, right, for the median, if I had a graph that looked like, like that, right, from this point to this point, the median is probably somewhere over here, right, because the area, right, the area over here has to equal to the area here, right? That's the median. Yeah. Now, in this case, visually, without any calculation, you can see that the mode is so heavily weighted towards the right that the area on the left over here looks much bigger than the area on the right. Yeah. So the blue area is much bigger than the pink. So therefore, the median must be like somewhere over here, right? The median must be somewhere over here, somewhere. So then the mode is bigger than the median based on the area, right? So the answer that they're really looking for is part B. Yeah. Since median is where the now where X, maybe just call where X divides the area under the curve, under the PDF curve in half by observation, the area to the left of the mode, you can put in brackets here, highest or maximum stationary point of PDF is much larger than the area to the right. Yeah, something along these lines, right? That's what they're looking for. So let me just move this up so I can put a conclusion. Something along these lines. Nothing mathematical, right? They just want you to know the concept, right? Therefore, mode is bigger than median. Yeah, that's all they're looking for. Something that basically demonstrates that the mode is the maximum stationary point, right? And the median is where the area cuts into two, right? And the area of the blue is much bigger than the pink. So therefore, the median has to be towards the blue side, right? To get the area to equal. Huh? All right, that was fun, right? That's 4 marks down. Now, the last 4 months, find the mode. Guys, find the mode. You're just going to differentiate and try to find the turning point. Now, what's important for you is to note that on this graph, there are 3 turning points, right? Stationary points right now. There's one over here, and the green one. I don't want this one, right? I don't want this one. I want the green one. I want this guy, right? The third one. So when I solve this, when I try to find the stationary points, right? It's probably going to give me multiple answers. I probably want the third biggest one from 0. Does that make sense? Yeah. So how do you find stationary points? Differentiate, right? Differentiate and solve. So let's do this now. So part C. So I'm going to define the function to be the PDF, right? So the PDF is K. Now, what was the formula? K sine. Okay, I found K as well. So I'm just going to sub it all in. So K is pi all over 2 plus 9 pi, right? and then multiply that by sine pi x plus 2x. Right? That's the function. Now, differentiate, solve, find maximum turning points. So find points, right? So differentiate that. So when I differentiate, so that's a constant that stays there in front. 2 plus 9 pi. Differentiate sine, you get pi in front, and then cos pi x plus 2. Yeah, pretty straightforward. Now, find stationary point, set that to 0. Set that to 0, the whole constant here goes away, right? And you get cos pi x equal to -2 on pi. Okay. Got to solve for cos, all right? Yeah, solve for cos. And I want the third answer, right? I want the third answer, which is the maximum turning point, right? So now, cos is negative. Now, ASTC, please, right? ASTC. I want the second and the third quadrants, right? Now, remember, radians. Radians is important. So, guys, if you, now, what's this one? This is pi minus theta. This is pi plus theta. So I'm going to find my equivalent reference angle in the first quadrant. So when you pretend it's positive, right, equals a 2 on pi. If you shift cos that, right? Oh, sorry, why did I write fraction there? Yeah, if you shift cos that, yeah, your reference angle is going to be in radians, right? So put your calculator radians 0.88 something, right? Yeah. Now, don't do anything silly there yet, because I want to sub this into there and into there to get the correct quadrants, right? Then pi x all right? I think if you type it in, you get so 180 minus that's a pi minus that, you get 2.26 something, and then you get 0.02, right? They're the first two, and then if you add sort of 2 pi to these, right, you get 8.54 and 10.31, something like that, right? And then divide it in by pi, right? Therefore, you get x equals to. So divide by pi, and you're supposed to get 0.72, 1.28, 2.72, 3.28, etc. Right? Now, remember, you're after the third answer. That's your answer, right? For the mode, you can see there's 3 stationary points, right? So therefore, the mode is going to be 2.72. Yeah, which makes sense-ish because like the mode is very close to 3 on the diagram, right? Yeah, so conceptually it has to be smaller than 3. But that's how you do it. Guys, that's a really nice question. And I guess a lot of students get stuck on this notion of mode versus median, even though mathematically, I believe part A and part C are okay. But last question in the test, 8 marks, might stump a few people. Guys, hopefully that was okay. If you enjoyed that, please like the video, subscribe to the channel, and tell your friends. Thank you very much.